Okay, we're looking at the Telescopic Cascode amplifier, and we noted that it has higher gain, but it also has lower voltage headroom and lower bandwidth. Let's examine the voltage headroom. So in terms of the input common mode range, let's look at the maximum input voltage that needs to exist across this amplifier. So we first note that we need a VBE, or I should say a VEB here, and a VEB on Q5. Q3 we need a VCE sat, and we need a VCE sat down to Q1, and we come back up to the base. So we can say that the base emitter voltage for this amplifier needs to be a VBE. So let's work down from the supply voltage. You know, this is VDD minus 2 VEB minus 2 VCE sat plus a VBE is equal to V plus. So we know that V plus can't be greater than this quantity, otherwise the amplifier will go into saturation, or some of the transistors will go into saturation. So we can say V plus, which is equal to VI max, has to be less than the above quantity. Alright, now let's work from the bottom side. So for VI min, we know that we need a VCE sat for Q12 and a VBE for Q1. Alright, now we also get a limited swing on the output, so let's see about our output. So our V out max, we need to keep Q6 and Q8 saturated. Q8 needs a VBE and Q6 needs a VCE sat. So we can say that V out max, or V out has to be less than VDD minus a VBE minus a VCE sat. For the low side, we know that we need a VCE sat, a VCE sat, and a VCE sat. So V out has to be greater than 3 VCE sat plus VEE in order to keep all the devices on and in the forward active region. Now, if we compared this to a simple non-cascoded amplifier, these limits are much larger than the non-cascoded amplifier, and hence the voltage swing is less. In the next lecture, we're going to look at using a folded cascode in order to minimize the impact of voltage swing on our amplifiers.